Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 11.1, Problem 11. This is Section 11.1, Problem number 11. It says, create and fill in your own chart to compute the limit as x approaches 2 of x cubed minus 8 over x minus 2. Now again, typically when we take a limit, my first intent is to just try and plug in the value that you're approaching into the function that you want to take the limit of and see what type of output you get. And the problem with this is, as I put in a 2 for x, the denominator becomes 0. So I could take this limit easily for any input value other than 2. I could take the limit as x approaches minus 2 would be okay, or as x approaches 5, or as x approaches 3, or negative 1. 2 is the only one that would really give me a problem. So I can't just plug it in and see what happens. My next approach would be try to do some type of factoring so that I can cancel out that denominator. Now in this case that can be done, but it's not a type of factoring that most people recognize easily. So if you don't, filling in a chart, as we did in the previous two problems, is always an option that you have available. It's quite tedious, but it'll always work. The previous two problems, the chart was already set up for you in terms of what would have to be inputted in some of the boxes. It was already written in. So in this one, we can fill it out. So to fill out the chart we have here, the function f of x, you want to write the function that's given in the problem. So in this case, it's x to the third minus 8 over x minus 2. And I'll write it again underneath. X to the third minus 8 over x minus 2. Now the input values are what went in the long narrow boxes here that we had done in the past. So since the critical value that we're approaching is 2, we want to input numbers slightly less than 2. Usually we do that in the top row. And then slightly more than 2 in the bottom row. You could do the slightly more than in the top if you wanted to. But traditionally, this row I would try an x value or input value of 1.9. That's slightly less than 2. 1.99, that's even a little closer to 2. And then 1.999. And then in the bottom row, again, value is very close to an input of 2. Slightly bigger this time. So we'll start with an input of 2.1. That's quite close to 2. Next, I'll try an input of 2.01. That's even a little closer to 2. And the last one I'll do is 2.001. So those are the input values that I'll use, and I'll do the computation and see what output we get closer and closer to. So I'll start with this first box where I'm going to put in an input of 1.9 for x. So the x cubed becomes 1.9 cubed, then minus 8, and in the denominator, x minus 2 is now going to be 1.9 minus 2. And again, that's kind of tough to do without a calculator, so you just run it through a calculator. It takes not even a minute. So 1.9 raised to the third power in the top. I get an answer, 6.859. I'm going to subtract 8 from that answer. Get a result negative 1.141. And divide by, I can see without the calculator, it'll be negative 0.1. And I get a positive 11.41 is my answer for that. So if I put in a 1.9 for x, I get out an 11.41 for y. So in the next box, I'm going to use 1.99 as an input for x. So the x cubed in the numerator is 1.99 cubed. There's minus 8. Underneath x minus 2 will become 1.99 minus 2. And again, I'll do the math, use the calculator. 1.99 raised to the third power for this part. I get an answer of 7.880599. I'm going to subtract 8 from that. Get an answer, negative 0.119401. Divide by in the bottom, I can see it's going to be negative 0.01. And I get 11.9401. When I put in a 1.99 for x, I get an 11.9401 for y. So now I'm going to try a 1.999 for x. So x to the third power in the numerator is 1.999 to the third power minus 8. And then x minus 2 underneath is 1.999 minus 2. And again, I'm going to rely on the calculator to do the math. Clear the screen. 1.999 exponent third power equals, I get 7.988005999. I'm going to subtract 8 from that answer. Leave the answer on the screen. Do minus 8 equals, I get negative 0.011994001. I'll divide that result by, I can see it's going to be negative 0.001. And the answer comes out to 11.994001. So if I put in a 1.999 for x, I get out an 11.994001 for y. So it seems that my output is approaching 12. Now let's see if the input values slightly larger than 2 also get close to 12. So the x cubed minus 8 will be 2.1 cubed minus 8. Then in the denominator, x minus 2 is 2.1 minus 2. So now to do the math, 2.1 third power gives me 9.261. I'm going to do 9.261 minus 8. The numerator is 1.261. Divide that by what's going to be 0.1. And I get 12.61, which is fairly close to 12. So again, I'm using an input that's close to 2, 2.1, and I get an output that's close to 12, 12.61. So now let's try an input that's even a little closer to 2, 2.01. So the x third power will become 2.01 to the third power minus 8 over x minus 2, so 2.01 minus 2. And do the math and see what you get. So 2.01 to the third power, calculator tells me that's 8.120601. So I'm going to subtract 8 from the answer I got. I get 0.120601. I'm going to divide that by the denominator, comes out to 0.01. After I do the subtraction. And the final result in this box is 12.0601. That's pretty close to 12. And one more box. X to the third power in the numerator is 2.001 to the third power minus 8. Then in the denominator, x minus 2 is 2.001 minus 2. Do that math. Clear the screen. 2.001 third power equals, get 8.012006001. 2 minus 8. I get 0.012006001. Divide that by, when I subtract the 2 here, it's going to divide by 0.001. And the answer comes out to 12.006001. Again, very close to 12. So as I approach an input value that's very close to 2, the output I get gets very close to 12. Again, I can't actually put in a 2 because it would zero the denominator. So I can't ever actually get out a 12, but I can get really close to it.